atoms. Now atoms are very, very small, so little dot here on this page, this dot here, well, in that dot there will be billions and billions of atoms, so a bit hard to imagine really, isn't it? Well, the atomic structure was first put forward by a guy called John Dalton, and all subsequent structures have been developed on that really. But everything starts with the nucleus. Now nucleus, as the name suggests, is right in the middle. Now nucleus, middle of the atom, contains what's called protons and neutrons. And the protons are positive charge, they're shown here by the yellow spheres, and we can also say the whole mass of the atom is concentrated inside the nucleus. So neutrons have no charge, protons have charge, and that's all concentrated in the nucleus. So nucleus is where most mass of the atom is actually concentrated. Now electrons, by contrast, are very, 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 very small. Okay, they move around the nucleus. So electrons in orbits around the nucleus, and they are the opposite charge to protons. If protons are positive, electrons are negative. They're very, very tiny, as I said, but they actually cover a lot of space. We said before the nucleus is where the mass is, but the electrons cover a vast amount of space outside the nucleus, and it's the volume of their orbits that actually determines how big the atom is. And as I said before, they have virtually no mass. They are, well, I'll give you a figure, about 1/2000th of the mass of a proton or of a neutron. And the shells are occupied around the nucleus, and these shells in fact help us to explain the whole of chemistry. They help us explain how reactive chemicals are and why they react in the ways they do. But before we do that though, let's think about some shell rules. Okay, electrons always occupy shells or energy levels. The lowest energy levels are always filled first. So looking at the diagram over here, these are the first energy levels, so these would be filled first. But the first one only holds 2. So the max we can have in the first orbit is 2. We've got 1 there and 2. And if your atom has more than 2 electrons, they start filling the second shell. So you can see you've got 1, 2, 3, 4, 5. So this one has actually got 7 electrons. And if my memory serves me right, this is actually an atom of nitrogen. 1, 2, 3, 4, we've got 7 protons. So we've got 7 protons and 7 electrons. So this is an atom here of nitrogen. And then if the second shell is full with 8, we go to the third shell, and that fills, and so on. Keep going that way. Now, if atoms could be happy, which they can't, but if they could be happy, they'd be happy when they've got full outer shells. So this one here would be happy when it's got 8 rather than 5 in the outermost shell, but that's for a later story. Now in most atoms the outer shell is not full, and this makes the atom want to react. In fact, if you know your periodic table, the only ones with full outer shells are group 0 or group 8, which are the noble gases. So how do we know how many electrons, protons and neutrons there are? Quite simply, we need to look at our periodic table. Now I hope you're familiar with your periodic table, and we just need to know 2 simple numbers, the atomic number and mass number. Here we got this symbol here for sodium. This is sodium. Sodium is Na. Now if you look at sodium in your periodic table, you'll see it's got 2 numbers, 23 here and 11 there. Now the bigger one, 23, is what we call the mass number. As the name suggests, it's all about the mass, and it's the total number of protons and neutrons. Do you remember we said most of the mass is in the nucleus, and the nucleus you've got protons and neutrons. The atomic number is the smaller number of the two, so here it's 11, and it tells you the number of protons you've got and also how many electrons. So in this atom here of sodium, okay, we've got 11 protons and 11 neutrons in the nucleus. So what about, sorry if that's wrong, let's cross that out a second, that's rubbish. 11 electrons outside the nucleus, ignore that, that's rubbish. Okay, so the atomic number tells us how many protons there are, also tells you the number of electrons there are. Now to get the number of neutrons, you just subtract the atomic number from the mass number. The mass number is always the biggest number. It tells you the absolute mass of the atom. So let's go back and cover my mistake, shall we? Awful mistake. 11 protons, we've got 11 electrons. Now to work out the neutrons, we simply look at the difference between these two values here. So even my basic math says that 23 minus 11 is 12. So you've got 12 neutrons and they have no charge. So 11 positive charges, 11 negative charges and 12 neutrons. in most cases the mass number is roughly double, so 23 is roughly double 11, isn't it? Okay, which means that in most atoms there's the same number of protons as neutrons, but they do differ, and that's for another story. Okay, so that is the end of the atom. There's a quiz now, so have a go and see you get on.